Have you ever wondered if it's possible to fix a crypto seed phrase that's missing words? Stay tuned for this tutorial on the math of cracking missing seed words. Hey everyone, this is Josh with a fun Bitcoin cryptography tutorial for you today. Yes, we're going to be discussing the possibility of cracking missing words from a crypto seed phrase. We all know as crypto owners that it's absolutely critical to back up your seed words in the correct order so that you can access your wallet in the event that the original device storing your keys is lost. It's interesting to think about this scenario because it entails partial recovery of cryptographic data. To just get this out of the way, if you lost your entire seed phrase, or really you lost about half of your seed phrase, there's no practical way to recover the coins in that wallet because the math becomes too out of hand. There's no computing in the world that is able to crack 128 or 256 bits of missing key data. And there probably won't ever be because these numbers are so big that any amount of computing power on Earth will never be able to keep up. That said, what if we're only missing one, or two, or three words out of our seed phrase? Is it possible to recover the coins? The first important thing to note here is that when we're talking about the BIP39 seed phrase and the BIP39 word list, you're not creating a seed phrase just by picking 12 or 24 words at random from that list. There's actually a special algorithm that is used to construct your seed. The algorithm starts with 128 or 256 bits of entropy or randomness generated by your computer's secure random source. That entropy is then encoded as the words, but the last word contains a special bit of information called a checksum, or a fingerprint. This basically allows the computer to validate that the preceding data is correct. So the fingerprint is generated from the main entropy generated by the computer. And this does change the equation a bit when we're talking about recovering missing seed words. So when we talk about cracking data in a seed, we need to actually think of these not just as words, but as bits of entropy. Each word in a BIP39 seed phrase represents 11 bits of data. That means that for every word, every slot in a 12 or 24 word seed phrase, there is 2,048 possible words to pick from the word list. But again, the last word is generated from not only some bits of random data, but also a checksum of all of the previous data in that seed. And what's important to note here for recovery purposes is when we have to do our guessing to try and figure out what the missing words are, we only have to guess the entropy bits. We can't guess the checksum because that includes a fingerprint of all the data in the seed. So essentially, if you're missing the last word, there's less actual bits of entropy to guess than there is with any of the other words in the seed. The last word contains 4 bits of a checksum for a 12-word seed phrase, and 8 bits of checksum data for a 24-word seed phrase. So let's break this down and talk about the practicality of actually guessing a certain number of missing seed words. Because again, whether or not the last word is one of the words that's missing does change the math a bit. So let's start with the simple case. And I'll start off by saying that all of the data shown here is for a 12-word seed for simplicity's sake. So let's say we're missing a certain number of words and the last word in the seed is not included. If we're missing one word, we're only missing 11 bits of data. And that is 2048 possible combinations for the computer to guess. And as you can imagine, modern computers are good at repetitive tasks. All computers are good at repetitive tasks. That's what they're designed for. And this takes seconds to crack. So if you're on a consumer computer, it might take anywhere from 1 to 4 seconds. If you have a pro cracking setup for this, it can take less than a second to crack one missing seed word. So that's totally practical. But as we go up in the number of missing words, this difficulty does not increase in a linear fashion. It increases in an exponential fashion, because every bit of data that's missing drastically increases the number of possible combinations to guess. If we're missing 2 words, we're now missing 22 bits of data, and we're in the millions of possible combinations. Now, this is actually still pretty practical for a modern computer, even with all the intensive computation that goes into cracking a seed. It is important to note here that cracking a seed isn't well optimized for things like GPUs in the same way that hashing operations are. So cracking missing seed words is going to be a bit slower and bound by the CPU power than other potential cryptographic operations. This could probably be done in about 2 hours for a consumer computer, and maybe on the order of minutes for a pro cracking cluster. So still very much within the realm of possibility. If you're missing 2 seed words and you have a decent tool and some computing power available, you may have luck in getting your full seed back. But when we start getting into 3, 4, and 5 missing words, we see how impractical this becomes and how exponentially this scales. If you're missing 3 seed words, we're getting now into the billions of possible combinations. And on a consumer computer, we're now talking potentially hundreds of days for this to work. Now, that's not necessarily impractical. If you have a much faster professional cracking setup, it could be done within a couple days. So 3 seed words missing is still fairly within the realm of possibility. But 4, now we're starting to get into trouble. With 4 missing seed words, not including the last word in the seed, we're now missing 44 bits of data. Now, by all means, 44-bit encryption is no longer considered secure, and we've moved on to 128 or 256-bit algorithms. But with how slow crack times are for doing something like a seed, there's so many combinations that it could take thousands of years, or if you have a professional setup, decades. You're very unlikely, unless you have vast resources and a highly optimized way to do this, to be able to crack 4 missing seed words. I would say it's potentially still within the realm of possibility, but very impractical. Now, when we get to 5 missing seed words, we're in the realm of pretty much impossible. This would be 55 missing bits of data. And at the rate that we could crack all of the possible combinations, which are in the order of 3.6 times 10 to the 16th power, this could take us thousands upon thousands, if not tens or hundreds of thousands of years. That's a big gap from maybe a decade, or maybe 30 days, or a few hours or minutes. This really hits home the exponential math involved here, so make sure your seed words are backed up. Now, let's talk about how this math changes a bit if the last word is involved. And we don't need to go through the table in the same depth necessarily. But having that last word included in the missing list does make a pretty big difference, because 4 to 8 bits of data changes a lot in our exponential calculations. So if we're only missing one word, we're only actually missing 7 bits of data instead of 11 bits. And now, for consumer or professional cracking, this would take under a second to guess. There's just not a whole lot of information to go through. For 2 words, we're missing 18 bits of data, which is in the realm of minutes or seconds. 3 words, we're missing 29 bits of data, which is in the realm of days to hours. But, once again, exponential math is hurting us here. When we get into 4 and 5 words, we're still starting to get into the realm of impractical or impossible to crack those words, on the order of several years to an impossible amount of years, like 100,000 years. So, if you're missing a couple seed words and you're looking for hope, I'm sure there are tools out there that can help you with this, or if you're tech savvy, you're a coder, you could probably write one yourself. This video is not about any particular tools that are out there. I haven't done any vetting on tools that claim to be able to do this. And I of course want to caution people that there are many recovery scammers out there that will claim they have some magic hack for getting back half of a missing seed or a whole missing seed. Don't believe them. They're just trying to trick you into giving them money or access to critical accounts or other seed phrases that you have. If you are missing 1 or 2 or 3 words and you have a decent computer, you may be able to find or code tools in order to crack your seed. But never give your seed information to anyone. There are so many recovery scammers out there. There are a few legitimate folks that will help people with this, but you need to be extremely careful, and really you should have tools to do this yourself. It is not wise to ever give seed phrases out to anyone. So I find this kind of math really interesting, even though I'm not a math person, because cryptography is fascinating, and it just goes to show the security of our seed phrases. If you have a properly generated seed of 12 or 24 words, nobody else will ever find that seed in the history of humanity. Nobody else will ever be able to guess it and steal your assets. They would have to steal them through some other means. But it does mean that it's important for you, the crypto owner, to always have several safe, secure backups of these words. If you lose all of them, you're not going to get them back. But if you spill a little coffee on a word or two, or maybe you forget to write one down because you're in a hurry, there might be hope. As always, I hope you have found this tutorial on Bitcoin seed cryptography interesting and informative, and thank you for learning something new with me today.